Today we are doing 6.6 rational numbers day 2, so we're basically going to be doing a lot of review from things that we talked about from yesterday's lesson. Yesterday we talked about what a rational number is. Read to me what the definition says. Any number that can be written in a fraction form. So we're going to do a few examples exactly like we did yesterday to make sure that you still understand how to do that. So go ahead and write this down, and I want you to do these 4 problems on your own. Let's talk it through. For 7, how can I write that as a fraction? 7 over 1, and that is the same exact thing as a 7. What is wrong with this problem right here?
It has a negative sign.
It's got a negative, so what do I have to do to the negative? Attach it to either the numerator or the denominator. So who can raise your hand and tell me one that you did? What'd you put?
I put 3 and negative 4. 3 over negative 4.
Okay, he wrote 3 over negative 4. Was there anyone who got something different? Gabby, what'd you get? Negative 3 over 4, right. So either one of those is fine. You don't have to write both options, just as long as you have one there. You do want it in A over B form, which just means it looks like a fraction. Looking at problem C, how do I write 0.5 as a fraction? 5/10? Can that be simplified?
Yes.
1/2. So your correct answer should be 1/2 because you always want to put it in simplest form. If you didn't do that, that's okay. Just make sure you fix it in your notes. And the next one, negative 2 and 2/9. What'd you get, Jakari?
20 over negative 9.
Okay, he got 20 over negative 9. Does anyone have a different answer? What'd you get, Katie?
Negative 20 over 9.
Negative 20 over 9 is also correct. Okay, how many of you would say you got all 4 of them right? Very good. Once again, if you didn't, that's okay. Just make sure you fix it in your notes and put it correctly. Looking at your handout that you see here, there are some ideas here that you've got to have memorized. Commutative order. Remember when we talked about commuting to school, driving to school, moving around, okay? You move from your house to the school. When you go home, you're moving from the school back to your house. So commutative property is all about moving or changing the order of your numbers. So the first one you can see here, 4 plus 3 equals 7. What is another way to just switch the order? What is it, guys? 3 plus 4 equals 7. This is simply telling you, hey, you can get the same exact answer even if you switch the order. Same thing is true down here. 3 times 4 equals 12, or what else could you say?
4 times 3 equals 12.
Notice you still got the same exact answer, so the order does not matter. We talked about the associative property. What was the key word for associative properties? Grouping. Okay, let's read these numbers right here from left to right. What's it say? 3 plus 4 plus 5. Read me these together. 3 plus 4 plus 5. When you read from left to right, were they the same exact numbers?
Yes.
Were they in the same exact order? Yes. What's the one difference?
They have parentheses.
They have parentheses. Just remember, parentheses tell us to do it first. So 3 plus 4 is 7. What's 7 plus 5? 12. Once again, over here, I've got to do whatever is in parentheses first. What's 4 plus 5? 9, and then add 3, and what do you get?
12.
So notice, even though I put right here different parentheses, or I had different groups, you still got the same exact answer. You can see the same thing is correct down here when you're multiplying. Let's talk about inverse properties. What's the key word for inverse properties? Opposites. Just remember, a number and its opposite will always equal 0 whenever you're adding. So keywords that you've got to remember. Additive inverse. The additive inverse is always going to be a 0 because 0 is the only thing that you can add to a number and still make it equal that number, okay? Oh, wait, I was just talking about the identity. Never mind. Additive inverse is adding an opposite, all right? So, next up, this right here, reciprocal. What is the reciprocal of 2/9?
9 inverse.
9 over 2. What's the reciprocal of 3/4?
4 over 3.
4 over 3. Okay, so just remember, if you multiply reciprocals by each other, then you're going to get the number 1. Final one. This is what I was just trying to talk about. Identity property. When we think of an identity, we think of who we are, all right? When you look into a mirror, you see yourself, okay? So just remember, for these words right here, additive identity, if you ever add something to a number and it doesn't change the number, what number would you have to be adding?
0.
A 0, okay? If you ever multiply something and try to get itself, what number do you multiply it by? A 1, okay? Let's just review real quick about the shortcuts that we want to know. Commutative property, what's the key word we need to know? Order. You can change the order of the numbers and it will not change your answer. Associative property, when you associate with people, it's your what of friends? Grouping. Your group of friends, okay? So you can change the grouping and it won't change your answer. Inverse, what's the key word?
Opposite.
Opposite. A number and its opposite will always equal 0. Last one, identity, is what? Mirror, okay? So what number can I add to a number and it will not change the identity?
The same number.
Not the same number.
It's a 1.
You can add a 0 and it still gets the same number. What number can I multiply things by and still get the same answer? A 1. Very good job, okay? Write this down for me. Evaluate the expression and justify each step we take. What do you think, Katie? What should I do first?
We have to use the commutative property, and we have to put 2.5 next to negative 2.5.
You are correct. Okay, why is that called the commutative property?
Because it moves it, it's like making a commute, moving from one place to another.
Very good job. Okay, I moved it around. It's like making a commute and moving those numbers from one place to another. All right, Katie, keep going. What do you think I should do next?
Then you and it's going to equal 0 because you're adding something against its opposite.
Okay, 2.5 and negative 2.5, we can cancel it out. She says it equals 0, and then we just bring down plus 4. Which one of our properties told us a number and its opposite always equals 0?
The inverse.
Inverse, good job. Remember that key word, opposite, okay? Very good. And what is my answer, Katie?
You get 4, and you're using the identity property because you're adding a number plus 0.
You are correct. We used the identity property because anytime you add a 0 to something, you're allowed to just get rid of it because that won't change the identity. Do you guys remember which two properties are best friends?
Inverse and identity.
Inverse and identity. So look right here. They are together like they normally are supposed to be. The one rule you do want to remember is the inverse property is always going to be followed by the identity property. Just like best friends, they are always together. So who wants to help me with this problem? We've got 2/7 minus 1/4 minus 2/7. JD, help me out.
So first you gotta use the commutative property and you do 2/7 and negative 2/7 and then negative 1/4.
Okay, now why is that called the commutative property?
Because you're changing the group
Not the group.
or the way it looks.
I am changing the way it looks because I switched around the what?
Your order.
I switched the order, okay? So as I switch the order, I just switched those two numbers. That's called the commutative property.
And then 2/7 and negative 2/7 cancel out.
Okay, which property tells me that it cancels out to become a 0?
Inverse.
The inverse, because a number and its opposite always equals 0. So what's my answer?
Negative 1/4.
Negative 1/4. Thank you for taking the negative sign with you because every number has a sign and that sign is directly in front of the number. So very good job. Which one of my properties told us that we could just get rid of that 0? The identity, because if you remember, if you add or subtract a 0, it does not change the identity of the number. How many of you followed along with him as he did that? Okay, any questions about how to do that problem? Okay. Okay, let's break apart what these things mean. The first one here says additive identity. Remind me again, what does identity mean?
Identity is here.
Okay, and identity is who somebody is, all right? Look at our number. Who is our number? 12, okay? So what can I add to 12 that will not change the identity? 0. So what's the additive identity?
12.
Nope. 0 is the additive identity because that is what you can add to 12 that will not change the identity. All right, so nobody got it correct. That's okay. Next up, additive inverse of 8. Let's break it down. What does inverse mean?
The opposite.
Opposite. So we're trying to think about what can I add to an 8 that would be the opposite of it. Who thinks they might know what the additive inverse of 8 would be? What do you think? Negative 8 is correct. Is there anybody else who wrote that down? All right, a couple people. If you didn't, that's okay. Just erase it and fix it, okay? The additive inverse of any number will always be its opposite. Let's break down the next one. Multiplicative identity. What does identity mean? Itself. Who a number is. Who is this number?
10.
Negative 10, okay? So let's think about this. What can we multiply negative 10 by and still get itself?
1.
The number 1. The multiplicative identity for every single number will always be 1 because you can only multiply something by the number 1 and still get the same identity. Last one. Multiplicative inverse. What does inverse mean?
The opposite.
Opposite. All right? So we're trying to figure out when we multiply. You got to look carefully at these words. When we multiply, what would the inverse be? Who thinks they know? It's not negative 1.
Negative 7.
It's not negative 7.
0.
Think about the opposite.
Negative 14.
No?
14.
Do you guys remember the word reciprocal?
What is that?
1 over 7.
This is 7 over 1, so what is the inverse of that? 1/7 is correct.
Okay.
All right, that's the last of our review for today over 6.6.